Before we begin, take a moment to get comfortable. Let your arms go heavy, your breath slow. And as you listen, feel free to leave a comment sharing what time it is, where you are, and what city or village you're listening from. It's love to know. And if you'd like more quiet stories like this one, don't forget to subscribe so they gently appear when you need them most. Now, let's begin. Beneath your feet, the earth hums in frequencies too low to hear. You stand on a landscape shaped by fire, but now cooled, crusted. Still, the air is ordinary. The sky doesn't hint at the depths beneath you. Trees rout calmly into the soil, unaware, maybe unbothered by what lies sleeping in the dark rock below. The wind rustles through the leaves, soft and forgetful, as if the earth has never burned, but the ground remembers. There are places in the world where silence is not peace, but pause, where quiet is not emptiness, but tension. These places do not smoke, do not bubble, do not roar. They sleep. And they have been sleeping for a very long time. You might be walking above one right now. The earth is not a solid ball, it is layered. Restless, alive, in slow motion. Its outer crust, where you live and breathe and build, is thin. It's beneath it. The mantle churns slowly like warm taffy, moving continents and shaping mountains in a rhythm that takes millions of years to notice. And deeper still, a core of metal spins, powering a magnetic field that protects you from solar storms you cannot see. This entire system is not calm. It only seems calm. Lake, whose surface mirrors the sky, while underneath, cold currents swirl and fish drift through forests of lightless green. A supervolcano lives in such quiet, unlike the volcanoes you've seen in pictures or on news. Ports, those sharp peaks with lava glowing down their sides. Supervolcano does not need a cone. It might not even look like a volcano at all. It may be a caldera, a vast sunken basin filled with trees and meadows and lakes, stretching farther than your eyes can see. It is quiet, it is still, and yet, it holds one of the most powerful forces this planet knows. You may wonder how something so immense could remain so silent. But that is the nature of pressure. It does not always shout. Sometimes it waits. Sometimes it settles itself deep in stone and holds its breath for tens of thousands of years. And the crust above the part you live on may not even tremble. It is not a question of danger, not yet. This is not a story to quicken your heartbeat, but to soften it, to remind you that even power can sleep. Even fire can be quiet. The earth is a patient storyteller. It speaks in time, millions of years ago. There were eruptions so vast they reshaped the climate, blackened skies, and cooled the oceans. But those moments are rare pages in a long book where most of the chapters are serene. Between each breath of eruption lies an era of stillness. Forests grow, rivers trace lazy curves. Animals make homes, humans forget, and that forgetting becomes the fabric of daily life. You drive across roads built on cooled lava flows. You picnic in calderas, now covered in grass. You sip water from lakes that filled the hollow left by fire. You do not think of magma. You do not think of ash. The world above has moved on. The world below has not. In Yellowstone, one of the largest supervolcanoes known, tourists gather to watch geysers spout and springs shimmer with color. The bison graze, the elk pass by, and under it all, a magma chamber stretches like a slow, glowing thought. Not dangerous today, not likely tomorrow. It's present. It's there. The earth's crust in that region is like a pot lid, cracked and uneven. Sometimes it rises, sometimes it's disillusioned. Geologists measure these movements with satellite data, watching the land breathe upward by inches. It is not alarming, it is not unusual, but it is alive, and that aliveness, so massive and slow and unnoticed, is what this chapter asks you to feel. What does it mean to live on something that waits? You've been taught to measure time in minutes, hours, maybe years. But the Earth measures in epochs. Its moments span lifetimes. Its pause between eruptions is longer than the entire history of written language. It has seen ice ages come and go, seen species rise and fall. Your presence here, in this breath of calm, is a miracle of timing. And still, you build homes, cities, power plants, parks, you name lakes and hike trails, and dig gardens on ground that is, in the deepest sense, uncertain. This is not a cause for worry. It is a reason to marvel. You are alive during a pause. You wake, breathe, sleep, and love during a moment when the world beneath you has chosen to be still. You do not need to earn this calm. K was given. Hey, and perhaps that's the most extraordinary thing of all. The earth does not need to announce its grace. It simply offers it. In South America, there is a caldera where clouds often cling to the rim. In Indonesia, entire villages sit inside in ancient craters, edges now forested, its floor fertile. These places once opened like mouths of fire. Now they cradle life, 'cause earth, like memory, can forget its rage. And you walk across it all, mostly unaware, like a dancer who doesn't notice the stage is made of glass. But perhaps that unawareness is part of the balance. Perhaps it allows you to live fully in the now, to sleep without scanning the horizon, to find peace in not knowing. Scientists study these sleeping giants with care, not panic. They drill cores and measure gas. They model eruptions not because one is coming, but because knowledge is power. And understanding replaces fear with fascination. You are not meant to be afraid of supervolcanoes. You are meant to respect them. They are the breath the earth holds, and now, in this quiet, you can hold your breath to not from fear, but from awe. Listen to the stillness. Beneath it, a story waits. A long, patient story, written in magma and cooled by time. The ground beneath you remembers more than you do. It remembers the first fire, the oldest silence, the lullaby of ash falling on ancient leaves. You don't have to remember it all, can't. You only have to listen. And so you begin here standing on crest. Cradled in calm, the earth is holding its breath, and somewhere, not far from where you sleep tonight, it's dreaming in silence, waiting not to awaken, but simply to be heard. For when you understand what sleeps beneath you, you begin to see that not all quiet is empty. Some silence is full of history, and some fire, despite its depth, despite its hush, still lingers beneath your favorite forest, just as the next chapter will show you that not all volcanoes were the face you expect. Imagine the word volcano, and you may picture a cone-shaped mountain, its peak smoking gently or erupting violently. You might recall photographs of lava trickling down the sides of Mount Etna, or grainy footage of Mount St. Helens spewing ash into the air. These are the volcanoes we know because they show us their drama. They roar, they flow, they leave behind scars in the shape of craters and hardened stone. Beneath your feet, a different kind of volcano waits, one that doesn't rise like a pyramid or shout with smoke. It is wide, flat, and quiet. So quiet, in fact, that people build towns and forests above it, never noticing the slumbering behemoth below. This is a supervolcano, and its power lies not in its height, but in its depth. Not in its frequency, but in its magnitude. Not in spectacle, but in scale. A supervolcano does not announce itself with steep sides or photogenic lava fountains. Often, it is invisible to the naked eye. To see it, you must learn to feel the earth in new ways, not as a stage for eruptions, but as a living crust stretched thin over hidden seas of molten memory. You walk across a grassy field in Wyoming. It's warm. Birds chatter, dies and graze. In the distance, beneath your boots, The Earth is solid, trustworthy. Far, far below, the crust gives way to a chamber wider than any city, a blister of pressurized heat, resting like a giant's breath, held and never exhaled. This chamber is not a chamber in the way we imagine rooms or caves. It is more like a reservoir, a colossal pool of magma, stretching for dozens of miles. And above it, the rock acts as a lid, a crust, yes, but also a question. How long will it hold? When scientists speak of supervolcanoes, they're not speaking of volcanoes that erupt more often or that look more dramatic. They are describing a rare geological formation with the potential to change the world, not just the landscape around it. Kaylee, a supervolcano, is defined by its capacity to eject more than 1,000 cubic kilometers of material in a single eruption. That's enough ash, pumice, and gas to blanket entire continents, to shroud skies for years, to alter climate for decades. The last time Earth experienced such an eruption, it dimmed the sun and changed the future of entire species. Word super is misleading if you're looking for noise. Supervolcanoes are not loud until they are. They are not tall. They are not even easily seen. They are super not because of what they do every year or even every century, but because of what they are capable of once in 1,000 lifetimes. Many of them don't even have a clear cone or caldera. Some, like Yellowstone, hide under green valleys and steaming geysers. Others, like Toba in Indonesia, disguise themselves as peaceful lakes. They are like old gods, forgotten by most, still worshipped by a few, always there, breathing beneath the surface. And just like ancient myths, they carry with them stories of destruction and rebirth. Scientists trace their fingers along the layers of rock and ash that surround these hidden giants and read a tale not just of fire, but of transformation. To understand a supervolcano, you must slow your thoughts. You must picture the Earth not as still, but as slowly shifting, always warming, always cooling, always pressing against itself. Plate tectonics push and grind, cracks form, heat builds. Beneath the crust, mantle plumes, columns of molten rock, rise like invisible elevators, carrying ancient heat upward. These plumes don't always form volcanoes at the surface. Sometimes they swell the land from underneath. Over thousands or millions of years, the ground arches slightly, as if breathing in, but this breath can last millennia. Eventually, magma collects in vast chambers, not just one pool, but layers, hot rock, semi-molten goo, gases under pressure. And then, in the right conditions, something shifts. The pressure exceeds the strength of the rock. The weakness opens. When it does, the chamber empties not in a slow pour, but in a sudden, world-shaking release. Shoots not just into the sky, but into the stratosphere. It rides jet streams, crossing oceans. Volcanic winters follow brief ages of cold and dimmed sunlight. Crops fail, rain patterns shift, life changes. Yet supervolcanoes are not evil. They are not waiting with malice. They are geological events shaped by physics and heat, by pressure and time. They remind us that we live on a dynamic planet, one that is still alive beneath its quiet exterior. Yellowstone is perhaps the most famous example in the modern mind, but it is not alone. It's a topwall volcanic zone in New Zealand. It's the Long Valley caldera in California, the Era caldera in Japan, the Phlegrean fields in Italy, and of course, Lake Toba in Sumatra, a lake so serene it's easy to forget it once altered the path of human evolution. Each of these places is not merely a dot on the map. They are breaths being held, lessons being written in magma and stone. To learn from them, we listen, not for noise, but for signs. We measure ground deformation. We track the chemistry of hot springs. We scan with satellites. We model with computers. Scientists have become the stewards of this knowledge, not to fear, but to prepare. And yet, there is something humbling in knowing that some forces are older than our instruments. that the Earth moves on timescales beyond our clocks. Some systems are so complex, they do not yield predictions, only possibilities. Living above a supervolcano is not reckless. It is ordinary. Millions do it every day. The difference lies not in risk, but in awareness. Because when you understand the shape of a supervolcano, you begin to see the Earth differently. You begin to understand that peace is not the absence of danger, but the presence of balance. That silence is not emptiness, but fullness held still. And in that silence, there is time. Time to learn, to wonder, to imagine what it means to live lightly on the surface of a world with such deep memory. You do not need to fear a supervolcano. You need only to respect the forces that shape our world, slowly, patiently, without needing your permission. The crust beneath your feet has held for thousands of years. It may hold for thousands more, but knowing what lies beneath changes how you see the surface. The grass feels softer, the air feels older, the moment feels larger, and somewhere in that awareness, your curiosity grows. 'Cause now you know the Earth does not shout its secrets, it holds them gently underfoot. As you rest, you may begin to wonder, where exactly is the closest of these sleeping giants? And how close? It's close, really? The journey, after all, has only begun. You step softly through a meadow veiled in morning mist. Wild grasses bend in the breeze. In the distance, bison graze, their shoulders like slow-moving mountains. But the real giant is hidden, not in the herd, not in the trees. Beneath your feet, beneath soil and stone, lies something deeper, something vast, something quiet, but never truly still. This place is Yellowstone. To many, it's a park, a wonder, a sanctuary, but to the Earth, it's a wound that never healed, only calmed, a scar that glows with heat, a breath caught deep in the chest of a sleeping planet. The land is gentle to the eye. Pools bubble, springs shimmer, steam drifts like spirit smoke between pines. The air smells faintly of sulfur, of minerals warmed from below. But beauty is a soft mask. Yellowstone is not peaceful because it's safe. It's peaceful because it's resting beneath the crust. Stretching miles wide and deep lies a chamber of magma. It is not a sphere, not a single pot of fire, okay? It is a complex web of molten rock and semi-molten mush. Parts pulse with heat, others cool into rigidity, moves like slow lightning, not bright and sudden, but warm and creeping, a liquid architecture constantly rewriting itself. The supervolcano beneath Yellowstone last erupted over 640,000 years ago, before humans walked this continent. Before we gave names to fire or sky, the eruption carved the land, painted the atmosphere with ash, and shifted the very climate. But it didn't end, it only paused. The evidence still whispers from the stone. Obsidian cliffs, born from cooling lava, caldera walls, remnants of collapse. The lake, serene and sprawling, filling the void where the land sank inward. Everything you see here, from the geysers to the hot springs, is part of that sleeping breath. And geysers, yes, they are the heartbeat of this place. Old Faithful is no myth. It is rhythm embodied, an eruption of boiling water, timed with a pulse of pressure below. You watch as it breathes upward, water arcing skyward in steam and roar, then silence. The ground beneath it prepares for another rise. It never hurries, never truly stops. Geysers are safety valves. They're how the earth exhales a little. Pressure builds, water superheats, then blasts upward. It is not dangerous, it is necessary, like a sigh through clenched teeth, but not all movement is seen. Much of Yellowstone's inner life is invisible. Satellites watch the land breathe. They track tiny uplifts, centimeters per year. The ground rises and falls like the chest of a dozing animal. Seismometers detect tremors. Not earthquakes in the usual sense, but gentle reminders that molten rock moves, expands, cools, heats. Again, a living chamber, not frozen in time, and all of it lies beneath life. You see tourists stroll boardwalks, unaware. Campers make tea as steam dances in the distance. Elk graze on sun-warmed hillsides. The surface lives in the now, while below, something ancient waits. It's easy to forget this. Easy to see Yellowstone only as a park. But every step you take is above a vast volcanic system, one of the largest in the world. Supervolcano. Yet, the term supervolcano can mislead. It implies drama, catastrophe, urgency. But Yellowstone is none of those things. Not now. Its danger is not in what it does, but in what it could do. Someday, maybe, perhaps. Its power lies in potential, not promise. And so, science watches, calmly, carefully. Geologists and volcanologists gather data from hundreds of sensors scattered across the park. They listen to the ground's low hum. They measure gas levels, carbon dioxide and sulfur dioxide, silent signatures of volcanic activity. They sample hot spring water, rich in chemistry, born from magma's breath. They are not predicting eruptions. They are reading mood, like doctors checking a patient's pulse, temperature, breath, and the diagnosis. Yellowstone is alive, but not angry. Its heat flows, its pressure shifts, but it does not roar. It dreams. This dream has shape. Scientists call it a magma reservoir. It's a zone of partially molten rock stretching under the park, about 30 miles long, 10 miles wide, and several miles deep. A second, deeper reservoir lies even further below, a deeper heart feeding the upper one. If it were ever to erupt again at supervolcanic scale, the consequences would ripple worldwide. But such an eruption is extremely rare. Millions of years. Rare. And even then, it would not begin without signs. Swelling, swarms of quakes, rising gas. Nature does not leap without first leaning. So you walk the trails. You watch steam rise from grand prismatic spring. A brilliant pool of color, so vivid it seems painted. Reds, oranges, blues, greens, each hue drawn from heat-loving bacteria and minerals. A rainbow written by geothermic breath. You feel small here and strangely safe, because Yellowstone is not a villain. It is a chapter in Earth's long, patient book. It's a place where fire met water, cooled into stone, and cracked open again. Over and over, there is something holy in that cycle. You imagine the heat beneath, not as a threat, but as warmth. Like the coals of a forgotten fire still glowing under ash, not roaring, not rising, just existing, reminding you that the ground you trust is not lifeless. It holds memory, energy, history. Yellowstone is a cathedral of the Earth's deep breath, and yet, for all its slumber, it connects you to forces beyond your lifetime. 'Cause even in rest, the magma chamber reshapes the land. It creates new geysers, heats springs, feeds bacteria, warms wildlife, shapes the ecology of this high plateau. The air smells of minerals. You sit by a bubbling spring, steam curling around your ankles, and for a moment you feel the age of the world, not as a burden, but as a blanket. The earth is old, but not tired. Yellowstone reminds you that even in dormancy, there is movement. Even in stillness, there is power. Not loud, not sudden, but deep, coiled, and ongoing. This is not a place of fear. It is a place of humility, a reminder that the most powerful things in life are often the most quiet. The mountain does not speak. The spring does not shout. But still, they change the world. You rise slowly, brush dew from your shoes, and look again at the quiet land around you. Steam rises in spirals. Quo. The bison move like old thoughts across the plain. Quo. The chamber waits, not to strike, not to surprise, but to be, and that is enough, because from the surface, Yellowstone seems still. But within its silence, the earth continues to write, layer by layer, heat by heat. It dreams, not of destruction, but of becoming, and tomorrow, beneath another quiet pool, another chapter of molten thought would drift upward, and cool dot, still hidden, still held, but never gone. Some fires do not fade, they simply sleep, and under your feet, one such stream continues, winding softly into the next. Next, you follow the path of magma itself, through its invisible flow and quiet architecture, keen to the anatomy of slumbering fire. There is a kind of stillness that feels alive, not empty, not inert, but dense with waiting. You walk above it every day across sidewalks, through forests, on desert rock. The earth holds you, but it also holds secrets. Beneath that ground, deep, where the light cannot reach, ancient rivers glow with heat. They don't roar, they don't burn, they don't announce themselves, but they move, slowly, like breath caught in stone. This is magma. Not lava is magma that has escaped. Magma is the dream that hasn't woken yet. The thought still forming in the mind of the earth. It is not just fire, it is substance. Slow stew of molten rock, crystals, gases, and suspended minerals, heated past imagination and pressed into silence by miles of crust. To understand a supervolcano, to truly feel the pulse of it, you must know how this fire rests. Start at the surface, where you stand. This is the crust, the cooled shell of our planet, only a few miles thick in places, like the thin skin that forms over hot soup. It creaks, it shifts, it carries mountains, cities, oceans. But in geologic time, it floats. Beneath that crust lies the upper mantle, and within it, magma reservoirs, chambers of heat and density that stretch wide and deep, like underground lakes of molten stone. They are not perfectly round. They do not slosh. They exist in shapes more like pancakes, in veins flat branching, following paths of weakness in the rock above. A supervolcano's anatomy begins here, with a primary magma source in the mantle, deep beneath the crust. In Yellowstone, this plume rises from hundreds of miles down, heated by the slow decay of radioactive elements and the enormous pressures of Earth's interior. As this heat rises, it melts the rock, it passes through, all of it, just enough. The result is not a pure sea of fire, but a hybrid. Some parts molten, some semi-solid, some gas. A chamber of possibilities. The magma gathers in layers at the deepest levels. It is hottest and most primitive, rich in heavy metals, iron, magnesium. As it rises and cools, it evolves. It becomes more silica-rich, more viscous, more likely to trap gases, more explosive if disturbed. Between the mantle and the surface, two main reservoirs often form. Yellowstone, for instance, has one shallower and one deeper chamber. Together, they are the lungs of the volcano, taking in new magma, mixing old with new, and occasionally exhaling. But this isn't quick. Magma doesn't surge, it seeps. It takes years to move a few feet, like honey through cloth, like ink through wet paper. Every rise is resisted by pressure, by rock, by time, and that resistance is what keeps you safe. Above the magma chamber lies what geologists call the cap rock, a rigid, cold crust of solid stone that holds the pressure below in check. It acts like a lid on a kettle. As magma gathers, it pushes upward, but until the cap weakens or cracks, nothing escapes. Beneath the cap, gases collect, volatiles, there, cold water, vapor, carbon dioxide, sulfur. These gases dissolve into the magma under pressure, like bubbles in a sealed soda can. But when pressure drops, say, if a crack forms, the gases explode outward, expanding violently and propelling magma into motion. That is the anatomy of eruption. But most of the time, the system does not erupt. It simmers. It changes. You might imagine these underground chambers as empty spaces, but that's not quite right. They're not caverns. They're zones, regions within the crust where the rock is partially molten, spongy, pressurized. Picture bread baking from the inside out, but never finished. Warm and rising, but held firm by the crust inside. The heat doesn't just sit still, it moves. It circulates in convection currents. Harder magma rising, cooler magma sinking. Over time, new magma injections from below push older material upward. This reshuffles the chemistry, the heat distribution, the potential energy of the system. This internal motion is silent, but we've learned to listen. Using seismic, tomography, echo-like imaging techniques, scientists can map these underground chambers. They bounce waves through the earth and watch how they change, revealing hot zones, mushy rock, fluid pockets, like an ultrasound of the planet's bones and blood. In Yellowstone, these images reveal a staggeringly complex system. The upper chamber sits between 5 and 10 miles below the surface. It's around 30 miles wide and 10 miles long. The deeper chamber is much larger, perhaps 4 or 5 times the volume, and sits 12 to 30 miles down. The two are connected by feeder zones, narrow conduits that allow material to migrate, mix, and accumulate. But again, nothing moves fast. And while these sizes sound terrifying, it's important to remember, volume doesn't mean eruption. The system can hold this energy for thousands of years without acting on it. Like a dam filled with water, it exists in balance till something changes. What causes the change? Sometimes, new magma rises from below, increasing temperature and pressure. Sometimes, tectonic shifts fracture the caprock. Sometimes, surface erosion removes weight from above, reducing pressure. It's never one thing. It's a conversation between systems, a long, quiet negotiation between heat and rock and time. And even when an eruption occurs, it doesn't always mean catastrophe. Supervolcanoes can and often release energy in stages. Small eruptions, hydrothermal explosions, ground uplift, earthquake swarms. All these may occur without a full-scale event. The system breathes before it speaks. Still, the anatomy of the slumbering fire matters, because it's the structured layers, the compositions, the pressures that determine the potential. And yet, inside this complexity, there is elegance. Each layer does its part. The mantle brings the heat. The reservoirs gather and evolve. The caprock seals the tension. The crust whispers clues to the surface. It's a choreography of patience. And from above, you wouldn't know. You see the geysers, the boiling mud pots, the hissing fumaroles. These are not eruptions. They are pressure points, vents, ways for the earth to regulate. It's like watching a sleeping creature adjust its breathing. Not in danger, just alive. Yellowstone reminds you that the planet is not dead rock. It is layered, molten, breathing geology, a system of systems, and it holds its heat like memory. There is a quiet beauty in how it's built, not random, not chaotic, but deliberate, slow, and held in balance by invisible rules. You imagine the magma moving gently, steadily, like a tide beneath the land. And you understand that even in its slumber, it is shaping the world, shaping springs, feeding ecosystems, carving rivers through warmth, writing its slow, glowing story in chambers unseen. It is not waiting to erupt. It is simply being, like a candle unlit, like music not yet played. And you walk above it, listening, breathing, trusting the layers that hold the heat beneath your feet, because there's something sacred in that structure. It's a kind of faith built into the bones of the earth, not in certainty, but in the calm of design. and that calm stretches into the next breath, the next layer, the next quiet truth of what happens when ancient fire meets ancient sky and turns day into night. Into night, you wake in a world of light, usually. Even when it rains or fog creeps low along the hills, there is a rhythm to brightness. Morning builds from the east. Tay afternoon expands the color of things. Evening cools the light like tea left to sit. But once, not long ago, in the language of the earth, that rhythm stopped and the sky went dark. Not in a blink, not like a storm, but slowly, thickly, like ink poured into milk. The sun didn't vanish, but it dimmed. Its warmth faded, its color changed, and the air filled with something dry and strange. It began with fire, but far away. Not in your backyard, not even in your country, but somewhere else entirely, where a sleeping volcano stirred, where pressure whispered up through rock, and magma surged into air. Not a mountain cracking at the top, but a basin caldera rising like a breath too big to hold, and then release, a super eruption. Not just lava, not just smoke, but ash. Billions of tons of it. Pulverized rock, shattered crystal, molten fragments, frozen mid-flight. Not fluffy, not soft ash that cuts, that burns, that hangs in the air like a threat you can't hold. When the Toba Supervolcano erupted some 74,000 years ago, it wasn't the first. It wasn't the first, and it won't be the last, but it was among the greatest in scale, and the marks it left stretch across the planet even now. It began in what is now Indonesia, a calm lake surrounded by jungle, basin formed from an older eruption, long forgotten. Beneath it, magma had gathered for thousands of years, layering, mixing, pressing upward, and then it broke through. The eruption lasted perhaps 2 weeks, not long in geologic time, but forever if you were beneath it. Entire forests vanished. The sky filled with lightning, made not from clouds, but from static, born of ash. Darkness fell before the sun had even set. The plume reached 50 kilometers into the sky past the weather, past the clouds, into the stratosphere where Earth's breath thins. There, the ash met wind, and the world began to change. Ash does not fall like snow. It floats. It rides tiny particles traveled around the globe, carried by jet streams that trace invisible highways in the upper air. Some of it settled across South Asia. Some reached Africa. Some crossed the Pacific. Some is still buried in the ice of Antarctica. It coated everything: leaves, roofs, streams, lungs. But more than that, did dim the sun. Ash and sulfur aerosols created a veil, thin but mighty, that wrapped around the planet and reflected sunlight back into space. Earth cooled, not just locally, but everywhere. Estimates suggest a global temperature drop of 3 to 5 degrees Celsius, enough to disrupt ecosystems, shorten growing seasons, to threaten fragile balances. Some researchers believe this volcanic winter may have lasted 6 to 10 years. For the people alive, then small bands of hunter-gatherers was a test. There are theories, still debated, that the Toba eruption triggered a genetic bottleneck in early humans, that only a few thousand survived, scattered across the continents, huddled in refuges of relative warmth. It's hard to be certain, okay? But what's clear is this: the sky changed, and life had to change with it. Ash chokes plants. It collapses roofs, contaminates water. It creates darkness where there should be light, silence where there should be birds. But it is also rich. Ash carries minerals. It feeds soil. After it falls, long after it becomes part of the ground, part of the next forest, the next harvest, what once burned becomes fertile. And in this way, fire becomes food. The sky, too, heals. Slowly, the particles settle. The sun returns. Clouds reform. Life adapts. And yet, even now, we remember the Lagaria eruption in what is now Colorado happened 28 million years ago. It was so massive that it ejected more than 5,000 cubic kilometers of material, an amount difficult to comprehend. If you filled the Grand Canyon with ash and stone, it still wouldn't match it. But La Guerrilla is silent now, a landscape of rolling stone and forgotten pressure. It sleeps, and no one panics. So why do we study these old eruptions? 'Cause they remind us that the planet is alive. They leave behind clues, tephra layers in sediment cores, ash markers in polar ice, soot in peat bogs, shifts in pollen counts, collapses in coral growth. Science reads these signs like you read tree rings or lines on a palm. Every marker is a whisper. This happened, okay? It could happen again, but not to scare you. It's not to haunt you. To show you that change is part of the pattern that the earth moves in. Cycles fire and ash, dark and light, silence and return, and that life, even in its smallest forms, persists. Lichens cling to lava flows, ferns sprout from cracks, birds nest in new branches. Human civilizations, too, have risen after fire. We rebuild. We remember. We plant again, and the sky turns blue once more. Sometimes it takes a decade, sometimes more, but always it comes back. The eruption of Mount Tambora in 1815, the most powerful in recorded history, brought a year without a summer. Too much of the northern hemisphere. Crops failed in Europe, okay? Snow fell in June in North America. Famine followed, but art followed too. Some say Mary Shelley's Frankenstein was born in that cold, gray summer, and Turner's sunsets, vivid with volcanic color. Oh, their fire to ash scattered high above. It's a reminder. Even disruption can create beauty. Even the darkest sky carries pigment, and so the past becomes more than warning. It becomes a guide. When we know what has happened, we understand what to notice. A ground that swells, a spring that changes temperature, a tremor not felt before. These are not panic. They are awareness, and with awareness comes peace, because when you know the sky once turned black, you can cherish every day it stays blue, not with fear, but with quiet awe, not with dread, but with respect. And that respect leads you gently into the next truth. That we are not powerless, not blind, but learning how to listen. Listen. You've seen lakes before, perhaps in the early morning, when mist rises gently off the surface like steam from warm breath. The water calm, so still it mirrors the sky. A heron gliding overhead, a ripple from a hidden fish. The world feels paused, like it's waiting for you to notice how soft it can be. But not all lakes are just water. Some are memories. Some are scars, and some are the resting places of giants. You gaze upon Lake Toby and you see serenity. A lake 100 kilometers long, nestled in the highlands of Sumatra, Indonesia. Green slopes cradle its edge. A small island, Samosir, rests near its center, shaped like a sleeping animal. Villages dot the shoreline. People bathe, children laugh. Boats cross slowly, cutting soft trails through the water. But below, in the deep, silence holds something older, something that changed the entire planet. Because Lake Toba is not simply a lake, it is a caldera. Vast depression formed when a supervolcano erupted with such force that the land collapsed in on itself. What you see now is the aftermath, filled with rain, with river, with time. But once, 74,000 years ago, this quiet place roared. The Toba eruption was one of the largest known in the past 2 million years. Estimates vary, but many agree. Over 2,800 cubic kilometers of material were ejected. Gas, magma, stone. The eruption column punched through the stratosphere. Darkness rippled outward. It was not merely local, not regional, but global. Toba didn't just destroy, it dimmed. Across the world, sunlight was filtered through a veil of volcanic dust. Earth's temperature dropped possibly by several degrees. Growing seasons shortened. Some species perished. The global climate may have cooled for decades, and deep in this story is you, or rather, your ancestors. Some researchers propose the eruption caused a genetic bottleneck in early humans, a moment when our species nearly vanished, reduced to perhaps a few thousand individuals scattered across the globe. Evidence for this remains debated, but the idea lingers like ash in wind that you might exist only because someone, somewhere, survived the dark. Lake Toba holds that memory, not in words, not in fossils, but in its shape, in its silence. Even today, the region is geologically active. Earthquakes tremble beneath the hills. Hot springs bubble near the shores. Scientists monitor the lake with cautious attention because beneath its calm face, magma chamber still simmers. But the land is in no hurry. Supervolcanoes operate on timelines that mock our calendars. Thousands of years can pass between breaths. And so, the people of Sumatra live with the lake not above it, not in fear of it, but with it. They farm the rich volcanic soil. They raise families in the shadow of distant memories. They believe in the spirits of the land, in the ancestry of fire and water. Their stories are not always scientific, but they hold truth, that the earth is powerful, that the past leaves marks, even under glassy water, and Lake Toba is not alone. There are other lakes like it. Lake Taupo in New Zealand, the caldera's last major eruption, nearly 1,800 years ago, was so large that ash fell across the Pacific. Chinese records described strange skies. The eruption's force reshaped the entire region, and today, the lake sits like a moon's eye, peaceful. Blue, deep. Crater Lake in Oregon, formed from Mount Mazama's collapse nearly 7,700 years ago, is another one of the clearest lakes in the world. No rivers flow in or out. It is fed by rain and snow, but beneath its clarity lies silence, hollow once filled with flame. These lakes, though far apart, share a story of collapse, followed by stillness, of eruption, followed by reflection, and in a quiet way, they remind you, even devastation can give way to beauty. The ash that once choked the air now enriches the soil. The craters, once carved by fury, now cradle live fish, reeds, birds, and reflections. The people who live along these lakes often do not think of magma. They think of seasons. They know when the fish arrive, when the mist returns, when the rains come heavy. Life moves forward. But scientists listen differently. They monitor seismic activity beneath the caldera floor. They use satellite imaging to detect subtle uplift signs that magma might be moving. They sample gas emissions near hot springs to sniff for change. And always, they remember what lies beneath, because lakes like Toba are not extinct. They are dormant, resting, brooding, waiting, but not threatening, not growling, just dreaming. And you wonder, quietly, what it means to live above something so ancient, so vast, to picnic on its shores, to paddle across its surface, to smile into its mirror. Does it make your life smaller or grander? Does it frighten you or ground you? Perhaps both. There is comfort in knowing that even the most violent parts of Earth's history can become tranquil. That time can smooth even the deepest wounds, and that people resilient, curious, brave can live not despite the past, but because of it. Lake Toba is a lesson that quiet is not emptiness, that stillness is not absence, that even beneath your favorite places, stories ripple outward, shaped by fire. And so, you look again at the lake not just for its beauty, but for its depth, not just its water, but its memory. Because when you stand at the edge of Tobowartapo or Crater Lake, you stand at the edge of the Earth's own breath, a place where the planet once exhaled completely and then paused. A lake is not just a lake. Sometimes it's the Earth saying, I've changed. I'm resting now. Listen. And in that listening, you come to the next realization. The smallest particle drifting across a sea or sky may carry the imprint of these ancient eruptions, then the ash may have even touched your life without you ever knowing. You stand on solid ground, but beneath you, the earth is never still. It stretches, sighs, pulses, cracks, each motion too subtle to feel, too slow to see, but they happened day and night, across continents and oceans, beneath forests and cities, and while you sleep, the earth speaks. Scientists, for generations, have learned to listen, not with ears, but with instruments tuned to the language of rock, its pressure and time. It begins with the SEISEOGAPH, a simple idea, elegantly executed. A weighted pendulum, suspended so delicately that it resists motion. Around it, the world can tremble, but the pendulum stays still. Its relative stillness, recorded against the shaking ground, comes as signature lines on a graph that trace the Earth's invisible pulse. Each earthquake, large or small, sends waves through the crust. Some ripple like water, others compress like sound. Some move fast, others slow. They arrive in patterns, like chords in music. By comparing when and how these waves arrive at different stations around the world, scientists can map the source, but they can also go deeper. These waves bend when they pass through different materials. Magma slows them down. Hot rock warps their paths. And by reading these distortions, like sonar in stone, we can glimpse the hidden architecture beneath our feet. It's called seismic tomography, a CT scan for the planet. Through it, we see chambers, slabs of sunken crust, pockets of molten rock. Not perfectly, not like a photograph, but like a dream, half remembered, enough to know that something stirs and where. In Yellowstone. This method revealed two vast magma reservoirs, one shallow, one deep, stacked beneath the park-like sleeping lungs. But seismology isn't alone. The earth changes shape before it, erupts, not suddenly, but slowly, a bulge, a swelling. The land itself rises as magma pushes upward, like dough rising under a cloth. To measure this, scientists use GPS, not for directions, but for millimeter-precise location tracking. A network of sensors fixed into bedrock sends signals to satellites. If one point rises even by a few centimeters over weeks or months, the system notices. A breathing volcano leaves a fingerprint on the crust. In Iceland, in Italy, in Indonesia, these measurements have become a vital early warning. A volcano that inflates is a volcano preparing, though not always, to erupt. It may deflate again, but the signal is a whisper worth hearing. Some scientists listen from above, in Sorrento for metric. Synthetic aperture method that uses satellites to take snapshots of the ground from space. By comparing two images taken days or weeks apart, they can detect subtle changes in elevation, if just millimeters. It's like watching the earth shift beneath its own weight. But even that isn't all. Volcanoes speak in heat, so we listen. With thermal imaging infrared sensors that detect rising temperatures on the surface. A patch of forest growing warmer without reason. A fumarole steaming more than usual. A glacier thinning from below. All of it tells a story. And then there's gas. Volcanoes breathe. Even when dormant, they emit gases, mostly carbon dioxide and sulfur dioxide. These gases rise from vents, mix with the wind, settle in air and water. By sampling them, scientists can infer what's happening below. A spike in sulfur may mean fresh magma is moving upward. A change in the ratio of gases can signal pressure. Shifts, drones, satellites, and field instruments all help sniff out these invisible trails. Each tool adds a layer of understanding. Together, they create a chorus. No single signal means certainty, but patterns emerge. Increased seismic activity, paired with surface uplift, paired with changing gas emissions. That's a conversation worth following closely, because supervolcanoes don't shout, they murmur, they hint, they reveal themselves in fragments. It takes patience to listen and humility to interpret. Scientists don't claim perfect foresight, okay? But they build model simulations of magma movement, stress accumulation, eruption scenarios, case. These models are fed by real data. They're tested, revised, compared against history. Some run on supercomputers. Others live in notebooks. Each one helps us ask, what if? What next? What might we see before we see it? And sometimes, what we see surprises us. Before the 1980 eruption of Mount St. Helens, volcanologists noticed a growing bulge on the mountain's north face. Daily measurements showed the land swelling by several feet. Earthquakes increased, gas emissions rose, and then, suddenly, the side of the mountain collapsed, triggering the most powerful landslide in recorded history. Followed by a devastating eruption. Warnings had been issued. Some listened, others didn't, but science had listened first and learned. Since then, monitoring networks have expanded. Every year, new sensors are deployed, new satellites launched, algorithms refined. Even machine learning now helps spot patterns that humans might miss, correlating signals across vast datasets, alerting researchers to anomalies they'd never thought to look for. Volcano listening is becoming smarter, quieter, more intimate, like a conversation between old friends where silence is as meaningful as words. And while we cannot predict eruptions with certainty, we can say this: they do not come from nowhere. The earth offers hints if we are still, if we are curious, if we are kind with our attention. There is beauty in that, to look at a landscape, peaceful, green, still land. No, it pulses. It's to hear the crust breathing. It's notice the tremble beneath your cup of tea. Not to fear it, but to understand it. Because fear shrinks, but understanding expands. You are part of this listening. Every volcano monitored, every satellite launched, every paper published, it exists not to alarm you, but to honor the earth's rhythms. And those rhythms, when heard deeply, bring peace. You are not standing over a trap. You are standing with a teacher, a being older than words, slower than memory, wiser than panic. And in this companionship, this listening, comes the next realization, that what lies beneath your favorite places may be more ancient, more powerful, and more poetic than you ever imagined. You breathe in. The air is calm tonight. Still, it holds no smoke, no dust, just a quiet swirl of nighttime wind. You feel it on your skin. Soft, clean, almost empty. But not all air has been like this. Not always. Once, thousands of years ago, you could have opened your mouth, and the breath you took would have been heavy with ash. So light, it floated like snow. So fine, it entered lungs without notice. So quiet, it circled the entire globe. Ash from one place, carried to all others. You are standing in a world shaped by particles. Tiny, unseen, but powerful. The eruption of a supervolcano doesn't just scorch the land nearby. It sends pieces of itself into the sky, millions upon millions of tons of ash and gas thrust high into the atmosphere, rolled upward with the power of mountain-sized engines. The sky becomes a highway for what was once underground. When Mount Toba erupted, it didn't stay local. Its ash drifted across the Indian Ocean. It settled on Himalayan snow. It fell gently onto what is now southern Africa. It seeped into lake beds in India, layered between sands and silt, waiting for archaeologists and geologists to one day notice. This is not metaphor, it is measurement. Toba has been found over 7,000 kilometers from its origin, and not just as a dusting, but as layers, centimeters thick in some areas. You may wonder, how does ash fly that far? It doesn't flap wings, it doesn't aim. It rides the stratospheric cold, dry highway above the clouds, where strong winds circle the globe. Volcanic ash, once fine enough, once hot enough to rise above the weather, gets caught in those winds and goes around the earth again and again until it falls like pollen, but heavier like memory, but physical, and each tiny shard tells a story. You cannot see a grain of ash with your eye, but under a microscope, it's jagged, not smooth like beach sand, but sharp, volcanic. It was once liquid fire, cooled into glass midair. It can be traced chemically to its volcano of origin. Scientists match these signatures like detectives match fingerprints. This means if ash falls into an ice sheet and that ice freezes, it holds time inside it. The Greenland ice cores tell such tales in the layers of ancient ice. Scientists have found volcanic ash from Iceland, from Alaska, from Indonesia, pieces of eruptions that no living soul remembers. And when they cut these cores, leave the past, each year's snow forms a new layer. Ash becomes a time stop. Black thread in white memory. It tells when the sky went dark, when crops failed, when summer never came. Even in medieval times, people remembered strange weather the year without a summer in 1816, when snow fell in June in North America, and crops failed across Europe. The cause? Likely the eruption of Mount Tambora in Indonesia. 1 year before, another massive blast, another ocean of ash that changed weather. Patterns ash that dimmed the sun. Ash that didn't need to scream to be heard, because it was everywhere. Even ash can cool the world. You think of fire as heat. You think of eruptions as burning. But volcanic ash in the stratosphere reflects sunlight back into space. It is a veil, not a blanket, a filter that dims the blue dot, and in doing so, it lowers temperatures. Crops grow slower. Rain's patterns shift. Even civilizations feel the ripple. Not always destruction, but change. Some historians wonder, did volcanic ash tip the balance in ancient empires? Did poor harvests trigger unrest? Did smoke in the sky become myth? Ash makes no sound, but it speaks, and it stays. In peat bogs, in ice sheets, in lake sediment, in the stone pores of ancient pottery. Ash records the memory of things we try to forget. It is nature's quiet ink. You might be asking, does this still happen, Kay? And the answer is yes. You may remember the eruption of a gale in Iceland in 2010. Not ACE for VOLCAN. No, not massive, but the ash. It closed airspace over Europe for days. Planes grounded, thousands stranded. All because microscopic shards of glass, harmless to lungs, but dangerous to engines, filled the sky. Air traffic halted. Silence imposed by dust. If such a small eruption can silence machines, what the ash of a supervolcano do? Not to frighten, but to wonder. Because what is ash, really? It is memory in flight. The body of a mountain returned to sky, and sky, after all, is everywhere. Perhaps some of that ancient ash is in the soil beneath your garden. Perhaps you stepped on it unknowingly. Perhaps it helped shape the rain patterns that fed the forests where your ancestors lived. Perhaps you carry it indirectly. In your DNA, we are more connected to the Earth's breath than we realize. You do not need to witness the eruption to be part of its story. You just need to be alive. Afterward, and here you are, alive, after thousands of years of ash and ice, sun and dark, breathing air that has carried memory. drinking water that fell through sky, dusted with the remnants of sleeping giants. Volcanic ash is not a curse. It's not a sign of doom. It's the earth rebalancing, shifting energy, making space. The ash isn't a threat. It's a reminder that everything is connected, that what happens in one corner of the earth touches all corners, and that silence can be as powerful as sound. So, next time the wind brushes your cheek, next time fog rolls low over your garden, next time the moon glows slightly orange through the haze, you might remember, ash crosses oceans, not with rage, but with reach, not to destroy, but to settle. And in its settling, it becomes part of the earth again, and part of you. Because even now, as you rest, the sky above holds stories waiting to fall, softly, without warning, but always with wonder. The ground breathes fire, but the sky catches the consequence. When you think of volcanoes, your mind might drift to fire and fury, molten lava streaming down hillsides, forests igniting, villages lost beneath clouds of ash. And yes, those moments do happen rare, powerful, dramatic, but in the deeper rhythm of time. It's the sky that carries the memory. The atmosphere remembers longer than the land does, because when a supervolcano exhales, it doesn't just change its surroundings, it changes the world's breath. Let's take a slow walk into this quiet but massive exchange between fire and sky. When a supervolcano erupts, it doesn't simply throw out lava. It launches something finer, something almost invisible. Microscopic ash, aerosols, sulfur dioxide. These float, drift, and swirl high into the stratosphere, so high that they escape the everyday winds that sweep weather across continents. So up there, they linger. Imagine a soft veil, not seen by the eye, draped over the world. It scatters sunlight, dims the warmth, blurs the edge of every season. A supervolcano doesn't just make noise. It draws a curtain across the sky. Perhaps the most famous example is the eruption of Mount Tambora in 1815. It wasn't even a supervolcano by classification, and yet it left the planet shivering. In 1816, across the northern hemisphere's summer never truly arrived. Snow fell in June. Frost returned in August. The sky turned to dull silver, and crops withered in confusion. It became known as the year without a summer. And that was not even the breath of a supervolcano. That was just a whisper by comparison. Now imagine what Yellowstone or Toba could do to the atmosphere's rhythm. Not as flame or flood, but as a climate shudder. Here's how it works. Softly, sulfur dioxide rises into the upper layers of Earth's atmosphere. There, it reacts with water vapor forming sulfuric acid aerosols. It's tiny droplets, light scattering, sun-bending. These aerosols don't just reflect sunlight, they shift the planet's thermostat. A little less light reaches the ground, a little less warmth touches the oceans. The result, slow planetary exhale of cold. This isn't the abrupt, terrifying cold of winter storms. It's the quiet chill of confusion, the kind that makes growing seasons shorter, harvests smaller, skies paler. Sometimes, even the colors of the sunset change. In the months after Tambora's eruption, the sky turned strange. Noah's noticed it. J.M.W. Turner captured sunsets tinted with lavender and crimson, not because of imagination, but because the light really was bending through particles that shouldn't be there. The beauty of it masked the weight of it. You see, when volcanoes influence climate, they do so silently. No sirens, no alarms, just a slow imbalance in Earth's energy flow. And for all our tools, our satellites, our forecasts, the sky doesn't give warnings in words. Some scientists believe that the eruption of Lake Toba around 74,000 years ago caused one of the most significant climate shifts in human history. They call it a volcanic winter. For up to a decade, the planet cooled. Rain patterns altered, plant life suffered. Some genetic studies suggest human populations shrank dramatically, perhaps clinging to survival in small bands. It's possible that fire in Indonesia changed the future of our species, not with flames, but with clouds. This is the strange paradox of supervolcanoes. They release heat to create cold. They burn the ground to dim the sky. Their fury leads not to firestorms, but to famine. And yet, even this is not the whole story, because Earth, even when shaken, keeps breathing. Okay? In the sky, though bent, finds balance. You might wonder, how do we know all this? How do we read the history of volcanoes and the weather? We look to ice. Layers of Antarctic and Greenland ice preserve tiny time capsules, specks of ash, traces of sulfur. By slicing deep into glaciers, scientists read the record of long-ago skies. Each eruption leaves a signature, and each signature speaks of a dance between ground and air. Some of those signatures span continents. That's how we know that a massive eruption in North America can send dust across the globe to be caught in the lungs of polar silence. And so, supervolcanoes aren't just geological events. They're atmospheric authors. They write chapters in a climate's book, sometimes brief, sometimes epic, and they don't always write in smoke. Often, they write in absence, the absence of light, the absence of warmth, the quiet rebalancing of seasons, unknown to most of us, until crops fail, until snows linger, till sunsets deepen to unfamiliar hues. But there's comfort here, too, 'cause this dance has always been, and Earth adapts. Volcanoes have erupted before. The planet has cooled and warmed, spun through cycles of frost and bloom, and through it all, life has learned how to bend, not break. There are mosses that thrive after ash, animals that migrate with memory, humans who plant new seeds in altered soil. Climate may dance with fire, but it doesn't surrender to it. So, what does this mean for you? It means the air above you is part of something older. Each breath you take was once shaped by a storm of stone. Each leaf you see may carry the legacy of ancient ash. Even the weather on your skin carries echoes of fire's silence. Supervolcanoes don't have to erupt to matter. Their very presence shapes the world's balance, because their power, whether awake or asleep, tugs gently at the threads that weave your sky as you drift tonight. Imagine the ash cloud high above, thin, silver, quiet, not hostile, just ancient. A reminder that Earth is alive beneath your feet, and the sky is its mirror, and that in the balance between eruption and stillness, you live every day within a story still being written. And sometimes, the story waits in stillness beneath the familiar lake, where a sleeping caldera hides beneath glassy waters, which leads us very quietly into the next chapter. You live in a world ruled by the tick of clocks, the flip of calendars, the quiet certainty of time measured in meetings, meals, and rising suns. You want things to be linear, predictable, logical. You mark birthdays, anniversaries, and deadlines. Your devices remind you when to rest, when to rise, when to water the plants, and when to call someone you love. And in the midst of all this scheduling, you hope quietly that the earth beneath you follows a similar plan. But it does not. Supervolcanoes do not wear watches. They do not count in hours or years or even centuries. They exist on scales your body cannot feel. Their tempo is not hurried. It is not even slow. It is ... UNMEASURED. Imagine, for a moment, standing on a beach. The waves arrive with a rhythm. Some soft, some rough, but always coming, always pulling back. You can feel their pattern, count their return. But now, imagine a wave that comes only once every 100,000 years. Would you even call that a wave, or just a memory of one, held by the sand? This is the rhythm of a supervolcano somewhere. Beneath Yellowstone, magma is moving. Not fast, not frantic, but shifting, inch by inch, over spans of time that would outlast empires. It collects, like breath, held in. You can't hear it, can't feel it, but it's there. And yet, you ask, when? When will the next eruption be? But nature doesn't answer in dates. It answers in layers, stone, sediment. It answers in fossils and mineral lines. It speaks in patterns, not predictions. And those patterns, even when uncovered, remain mysteries laced with uncertainty. Scientists do not know when Yellowstone will erupt again. They do not pretend to. Instead, they watch, they measure, they learn, not to offer you certainty, but to offer you understanding. Understanding, after all, is softer than certainty. It bends, it listens. The last time Yellowstone erupted in a truly colossal way was about 640,000 years ago. Before that, 1.3 million years ago. And before that, 2.1 million. These are vast spaces of time, so wide that even imagining them feels like floating. And from these gaps, you may try to draw a pattern. But a pattern is not a prophecy. You may think it's overdue. But volcanoes don't follow appointments. The earth is not late. The earth is simply ... itself. There are smaller signs, of course. Earthquakes flutter beneath the surface. Geysers behave erratically. Gases shift in concentration. The crust rises and falls, like a breath you cannot hear. But none of these signs point with precision. They whisper of movement, not eruption. Of change, not climax. And so you wait. Not for an alarm bell, but for deeper understanding. This waiting can feel uncomfortable. You are a creature of cause and effect. Something stirs, you want to know what will follow. The stove is hot, you don't touch it. If a storm is coming, you close the windows. But what do you do when the cause might never bring an effect? What do you do when the storm brews in silence for centuries? You learn to live with uncertainty, and maybe that's what supervolcanoes teach best. Not fear, not doom, but humility, A reminder that not everything must resolve, Not everything must climax, Some things just are. Imagine reading a novel where the ending is never written. At first, it might feel wrong. But then, slowly, you begin to notice the details, the way the character holds their breath, the way the wind shifts in the trees, the scent of something burning in the distance. You begin to live in the middle, not rushing to the end, just ... being. That is how we must live with supervolcanoes. They are not threats to be feared, but stories to be studied. They hold knowledge, not doom, and their uncertainty is not danger, it's depth. Think of how many things in life are truly predictable. Not many. You don't know what someone will say when you open the door. You don't know what your thoughts will feel like tomorrow. You don't know when love will arrive or when silence will fall. And still, you live. Still, you breathe. So too with Supervolcanoes. Scientists develop models, beautiful, intricate, complex. They simulate eruptions, track magma flow, watch gas levels. They observe, they refine, but they do not claim to know exactly when, because knowledge is not the same as prediction. To listen to the earth is not to control it. It is to respect it. Every tremor beneath Yellowstone is logged. Every shift in ground elevation is noted. Every change in heat, every pulse of gas, every movement of crusted is all watched. Not with fear, but with wonder. And slowly, through this watching, a different kind of certainty forms. Not the certainty of dates, but the certainty of dedication. The knowledge that if something changes, truly changes, we will know. Not instantly, but soon enough. From there, choices can be made. You might wonder, how much warning would we get? No one knows for sure, but likely weeks, maybe months. Science would stack like gentle footsteps. Earthquakes would become more frequent. ground would swell, geysers would grow erratic. The land itself would begin to tremble with a new kind of breath. And even then, the moment might not come. The pressure might ease. The magma might settle. The story might pause again, because eruption is not destiny. It is possibility, and possibility is wide open, unknown. This can be comforting if you let it be, 'cause it means the world is not bound by fate. It means that stillness is not just a pause, it is a state of being, state that can last generations. And during that stillness, life thrives. Forests grow over ancient scars. Bison graze above molten chambers. Children laugh near geysers. Tourists take photos of steam that rises from the earth like breath. You live above a mystery, but it does not chase you. It holds you, and in that holding, you can rest. There is beauty in not knowing. There is peace in not needing to know. You do not ask the moon when it will wane. You do not ask the wind when it will still. You simply watch and feel and accept. So you walk. You walk above Yellowstone or Toba or Topo. You walk on crust, both ancient and new, and you do not fear it. You honor it. You honor the silence beneath your steps, and in doing so, you join the earth in its quiet rhythm. You move not with panic, but with patience. You trust not in timetables, but in awareness. You let go of needing a sign, because sometimes the absence of certainty is the truest gift. It frees you. It returns you to the moment. And in that moment, beneath your feet, something ancient waits, not to erupt, but simply to be known. And as you let that thought settle, like ash falling softly over time, you begin to wonder not about when the next eruption will come, but what happens after it has passed, what grows, what heals, what begins again. And that is where the next part of this journey will take you. The fire has passed. The mountain that once roared has returned to silence. And in that silence, a new story begins, not one of violence, but of return. You stand at the edge of an old lava field. The rock beneath you is black, cracked, and lifeless. At first glance, it is still warm in places, hardened in others, like a scar healing slowly over time. There are no trees here, no soft grass. It's just a jagged plain that speaks of firestorms and skyfall. But wait, bend closer. There within the fractured folds of basalt and obsidian, a lichen blooms. It's not a bloom as you might imagine it. There are no petals, no fragrance, but just a faint green-gray patch clinging to stone like a breath made visible. And that lichen is the beginning, the quiet herald of nature's return. Lichens are patient settlers, neither plant nor animal. They're symbiotic creatures, part fungus, part algae, living together in a mutual embrace. The fungus offers shelter, clinging to stone-like skin, while the algae gathers sunlight and makes food. They ask little, survive much, and together they begin to wear the lava down molecule by molecule, grinding eternity into dust. That dust becomes the first soil, a thin smear, barely enough to hold a droplet of water, but it's enough. Next comes moss, tiny, resilient, soft. It doesn't need much, just a bit of moisture and a foothold in the crevices left behind by cooling lava. Mosses spread slowly, like memory, and cover the rock in a dull green hush. They retain water, make more soil, and welcome the next chapter of colonists. Now the real transformation begins. Seeds arrive, carried by wind, by birds, by sheer accident. Some fall into the cracks, others lie dormant until rain or sun stirs them into life. The first plants are pioneers, fast-growing, hardy, low to the ground. Ferns, grasses, scrubby shrubs. They live short lives but die rich, offering organic matter to the growing soil. Insects follow them, beetles, ants, tiny spiders. And when insects thrive, so do the creatures that feed on them. small lizards, ground birds, rodents. It is a slow, deliberate layering of life. Nothing rushes, nothing is wasted. Everything waits for its moment. After decades, sometimes centuries, the area begins to resemble a meadow. Small trees arrive: willow, birch, pine. Not many, not tall, not yet. But they take root. Their roots dig deep, fracturing rock further, allowing air and water to penetrate. Fungi follow the roots underground, creating vast mycelial, web-silent communication networks beneath the soil. These networks help trees share nutrients, warn of drought, and balance their needs like neighbors leaning over fences above ground. Birds nest. Their songs return to places once scorched by ash. Their feathers scatter more seeds, and their waste feeds the earth. Deer may wander in, foxes may prowl, amphibians return when the rains gather in the craters, turning calderas into lakes, basins into wetlands. Frogs croak where magma once churned. It is not dramatic, it is not quick, but it is happening always. Where fire once ruled, life patiently rewrites the terrain. You might think lava ends a forest, but really, it resets it. It levels what was built. It creates new soil rich in iron and minerals. It balances the old with a chance for the new. Scientists call this primary succession, technical term for the miracle of beginnings. They study places like Mount St. Helens in the U.S., where after the 1980 eruption, entire valleys were buried in ash. People feared they'd be sterile for centuries, but the very next spring, lupins sprouted. Wind-blown seeds had found purchase in the dusty, nutrient-rich land. By year 3, insects had returned. By year 10, rodents scurried beneath shrubs. By year 30, new forests took shape. The same has been observed around Krakatoa, Mount Pinatubo, and Lake Toba, in places where the earth screamed. It eventually whispered. A gond life heard that whisper. This resilience is not just a biological curiosity. It's a reminder that endings are seldom as final as they seem, that the planet has its own rhythm of renewal. It makes you wonder what else begins after catastrophe. In your own life, perhaps, there are eruptions, moments that level you, to burn away the known, leave you standing in silence, wondering what could possibly come next. And yet, somewhere inside that silence, something waits to begin. Something slow, small, beautiful, like a spore on the wind, finding its first stone as you watch this landscape shift from black to green, from ruin to refuge. You begin to see that life doesn't just recover. It transforms, becomes richer, more layered, more adapted than before. The lava doesn't erase the past, it feeds the future. And just as the earth remembers fire, it also remembers how to grow. Even the most violent volcanoes eventually give way to forests. Even the bleakest moments find color again. It's not optimism, it's geology, it's biology, it's truth. So breathe slowly, deeply, here at the edge of the lava field. The air is clean, the ground is warm, the silence is not empty, it's full of beginnings. You might not hear it right away, but beneath the soil, life is writing its return, and that quiet sound of roots pushing through stone, it's louder than any eruption. Still, as the green takes hold and the forest stretches once more toward the sky, you can't help but feel a sense of wonder. Not only at life's return, but at the forces that allow it. How does the earth balance destruction and renewal so delicately? A tile, pressure not, motion shaped this world from beneath. And in that question, you begin to feel the slow rise of the next chapter. Pressure is not always noise, not always explosion. Sometimes pressure is stillness, collected, controlled. It's invisible as you lie quietly and think of the earth. Remember this: deep beneath the crust where you walk, where trees sway and cities hum with light. Something vast and unseen is building, not by choice, intent, but by the laws of the earth itself. The core of this planet radiates heat, primordial warmth from its birth, mixed with the decay of heavy elements like uranium and thorium. That heat moves upward, slowly, relentlessly, and as it rises, it melts. Rock, not in open pools, but in patches, pockets, thick and heavy like syrup, locked within a sponge. Magma. But magma doesn't burst upward without reason. It doesn't search for a way out like water or wind. It waits. It collects. It deepens. It learns the shape of the space around it. This is pressure. Imagine holding your breath not for seconds, but for centuries. Now, imagine the Earth doing the same. Entire magma chambers, like the one beneath Yellowstone, expand and contract in pulses. Not in days, not even in decades, but in cycles that last tens of thousands of years. Each movement so slow you'd never know it's happening. And yet, it is. Over time, molten rock fills voids created by shifting tectonic plates. It pushes against the crust from below, like a deep sigh against a ceiling of stone. It doesn't seek drama, it simply obeys physics. The crust Earth's outer shades isn't smooth or even. It is fractured, stressed, and constantly under tension. When magma accumulates, it exerts upward pressure. But the crust resists. Its balance between push and hold, between molten flow and solid stillness is delicate, powerful. Now imagine this happening silently beneath a meadow or a lake or a city. The magma is there, always there. It doesn't forget, doesn't sleep. It simply exists in a state of preparation. You see, supervolcanoes do not erupt because they are angry. They erupt because the balance tips. The pressure builds slowly as more magma enters the chamber. Each pulse is subtle. Scientists detect these movements as the ground lifts slightly millimeters per year. Seismic waves echo differently. Gases begin to rise, hinting at change. But it might take thousands of years for these signs to mean anything. Patience is part of the process. Think of how mountains rise. Not in storms, but in slow collisions. Two tectonic plates pressing together inch by inch over millions of years. The Himalayas were not born in a moment of fire, but in a gradual, grinding hug of continents. Pressure lifted them skyward, quietly, and so it is with magma. Beneath the caldera of a supervolcano, the molten rock is not one pool, it's a layered system. There are hot spots and cooler patches, viscous zones and crystalline sections. Some parts rise, others cool. Crystals form and float, changing the chemistry of the melt. All of this occurs in darkness, under silence. It's a slow alchemy shaped by heat, time, and confinement. When the pressure becomes too great, when the rock above can no longer contain the molten mass, it fractures. And what follows can be catastrophic. But here's the truth most miss. The eruption is not the story. The patience before it is. Yellowstone, for instance, hasn't had a supereruption in over 640,000 years. During that time, humans evolved, walked upright, built fires, carved tools, painted caves. And all the while, the magma beneath Yellowstone waited. It expanded and contracted. It reconfigured itself. Sometimes, it released a little pressure geyser here, a hydrothermal explosion there. But mostly, it was still in that stillness. The earth teaches us something profound. That power does not require urgency. That change can be slow. That pressure, when held with patience, potential, and this isn't just geological. It's human. In your life, there may be pressure, internal, unseen. It might rise quietly beneath your surface. It might build over years, but that doesn't mean it must break. You can learn from the Earth's magma chambers. from its deep silences, from its waiting. Holding pressure is not weakness. It is preparation, and the longer the wait, the more refined the eruption, should it ever come, will be. Scientists now study this patience. They look at rock cores drilled deep into ancient calderas. These samples reveal histories of slow growth. Each layer of cooled magma speaks of different compositions, of repeated fillings and emptyings, of pulses that didn't erupt, of tension that did not result in violence. There's even evidence that some supervolcano systems never fully erupt at all. The pressure releases through minor leaks, through hydrothermal systems, through ground swelling that calms again. The earth can self-regulate if the crust is forgiving enough. If the system is balanced. That's the secret. Pressure on its own is not dangerous. When balance is lost, that eruption becomes inevitable. The challenge is knowing when that tipping point arrives. This is why monitoring matters. Not because we expect a super eruption tomorrow, but because every signal helps us understand the language of pressure and time. Seismologists listen for tremors. Geologists read the rock. Satellites scan the breathing of the land. Earth is always talking. We're only just learning how to listen. And what we hear, more often than not, is stillness, is patience, it's waiting. Take Mount Mazama in Oregon. It's once held a massive volcanic system, but when it finally erupted around 7,700 years ago, it collapsed into itself, forming Crater Lake. That lake now sits serenely, a mirror of sky, its surface a reflection of peace. But beneath that peace is the story of pressure of centuries, of silence before a single transformative event. Or look at the Long Valley caldera in California. It hasn't erupted in modern memory, but it, too, holds potential. Pressure gathers, cages shift, and yet nothing violent happens, because patience holds, balance remains. What these ancient systems remind us is this: not all power needs to express itself. Some of it lives quietly beneath, shaping, building, waiting, just like you. You are shaped not only by your moments of expression, but by your long periods of stillness. By the times you waited, held space, balanced your inner pressure. You are not broken for carrying pressure. You are the earth holding its breath. And when release comes, it will not be a breaking. It will be a transformation. A fire will write new landscapes, okay? The ash will see new life. But even then, it is the waiting that mattered, okay? The patience that defined the shape of the story. So tonight, rest in this understanding beneath the ground, beneath your skin, beneath the sky. Pressure builds not to destroy, but to shape. And the longer it waits, the more magnificent the change can be. Stillness is not emptiness. It is preparation in its purest form. And if you listen closely, beneath the hush of the earth's crust, you may hear it. It's not a roar, not a crack, but a deep, slow breath, waiting for the next shape to begin. And in that breath, you sense something else rising, not from pressure, but from place. You wake up, brew your morning tea, step barefoot onto your porch, and stretch toward the sun. The earth beneath you feels solid, dependable, but it isn't. Not truly. What lies beneath is a layered, exterior crust, just thick enough to fool you into thinking it's safe, steady, permanent, but it's not, okay? And somehow, even knowing this, we live as though it is. You are one of billions. Billions of people living not just on the earth, but above its most powerful, unpredictable heart. Its entire cities rest on crust that is thinner than a sheet of paper when scaled to the planet. It flexes, cracks, shudders, and we build highways on it. Skyscrapers, schools. Take Yellowstone, for example. Each year, millions of visitors wander its boardwalks, peer into steaming geysers, marvel at the brilliant pools of color. They don't see the molten chamber 2 miles below. They don't feel the heat accumulating in a reservoir the size of cities. And even if they did, they wouldn't stop. they would still take photos, still book cabins, still sleep under stars, whose light took millions of years to arrive, because that's what humans do. We carry on. It's not denial, it's resilience. We don't live in ignorance of what lies beneath us. We live in defiance of it, in harmony with it. Even in the shadow of a supervolcano, life continues. It plants gardens, it hums lullabies, it shares meals. The ground might pulse, it might swell ever so slightly, but as long as it holds, we stay. And yet, there's something strangely poetic about this dance we perform above the furnace. When the last eruption shook the land now known as Yellowstone about 640,000 years ago, our ancestors were barely recognizable as human. They carried stones, not smartphones. They spoke in gestures, not languages. And still, they probably felt the rumble underfoot. Still, they probably looked to the sky, unsure what it meant. Fast forward to now, and we live more connected than ever. We track earthquakes on our phones. We read satellite data. We watch time lapses of shifting ground. And yet, we still can't predict exactly when a supervolcano will erupt. That's the paradox of human knowledge. We know more than ever, and yet certainty remains just beyond our reach. So, what do we do with this awareness? How do we live knowing the crust beneath us may one day crack open? We keep planting, we keep building, we keep telling stories, because the alternative, waiting in fear, would rob life of meaning. Our strength lies in not needing guarantees. Consider the town of Naples, Italy. It rests in the shadow of Mount Vesuvius, a volcano, infamous for burying Pompeii in ash nearly 2,000 years ago. The mountain hasn't erupted in decades, but the people remained. They raise children there. They harvest grapes from volcanic soil. They celebrate festivals in the shadow of history. Not because they've forgotten, but because they remember on choose life anyway. Or think of Rotorua, New Zealand, a town built within a geothermal wonderland. Dia smells of sulfur. Steam seeps from the ground. Mud boils in open pits. But instead of fleeing, the Mbori people made it home. They used the hot springs for healing, for warmth, for cooking. They found harmony in detention. We are a species that settles in lava zones, that farms on floodplains, that flies metal through lightning, that sleeps near rivers known to rise, and all of it, every act of daily life, is a quiet statement of courage. You, too, live above a furnace. Even if there's no volcano nearby, the heat is there. The magma flows beneath your house, your city, your favorite forest trail, and still, you live. You worry about missed calls, misplaced socks, unfinished books not about calderas, and in a way that's beautiful, because it means you trust a moment. You choose to live within it, and that's where humanity thrives, not in control, but in presence. Think of the ancient people who first settled near Yellowstone. Archaeological evidence shows human activity around the park dating back at least 11,000 years. Crafted tools from obsidian, the volcanic glass left behind by past eruptions. They used geothermal features for warmth and cooking. They didn't know they were living above a supervolcano, but they knew the land offered something powerful, something worth staying for. And still, thousands of years later, we do the same. We live above fault lines. We drink water filtered by ash layers. We farm soil made fertile by past eruptions. Even destruction leaves behind gifts, because fire, when cooled, becomes foundation. Ash, when settled, becomes soil. And danger, when understood, becomes design. That's the genius of humanity. We build, not in spite of nature, but in dialogue with it. We watch mountains and learn from their shape. We monitor tremors and prepare for their stories. We build models not just for survival, but for understanding. In recent years, science has created detailed simulations of supervolcano behavior. These models don't just predict eruptions, they explore timelines, vent, locations, gas dispersion, and how ash might travel. It's like drawing a map of a mountain stream. But even with this data, uncertainty remains. That's why we build, not just with science, but with hope. We construct not only buildings, but communities. We teach children how the earth works, and also how to love it. Because that love, that reverence for the land is what grounds us above the magma. We plant trees above the faults. We write music above the silence. We speak joy, and in every quiet moment, acknowledge something deeper, that to be human is to be fragile and to live anyway. It's not foolishness, it's faith. It's not in superstition, but in rhythm. You see, the earth is not just a threat, it's a partner. Its eruptions cleared the way for rebirth. Its heat fuels geysers that awe and heal. Its unpredictability keeps us humble. We don't dominate this planet. We walk with it. Yes, we may one day witness the awakening of a supervolcano. Yes, ash may fall again. Yes, cities may need to adapt. But even then, we will remain, because we are not defined by fear. We are defined by what we create in its shadow. A garden, a melody, child's laughter on ground that once shook. And in this fragile, uncertain balance, this life above the furnace, we find our place, not above it, not against it, but within it, softly, patiently, like trees growing from cooled lava, like hope rising from Ashdod. And in this quiet understanding, we begin to see that awareness doesn't weaken us, it makes us whole. For the more we know of what lies beneath, the deeper our roots can grow. And with roots deep, we stand strong even when the world shifts, even when the sky dims, even when the next chapter begins beneath our feet. You don't need to panic to pay attention. You don't need to fear something to understand it. As you lie still tonight, the world continues to turn, and beneath that turning world beneath you, beneath the ground, you know there are places where fire waits, where ancient magma hums with pressure, but no sirens sound, no clocks count down. There is only the slow, soft vigilance of science, unlike the mind when it races. It's patient. It listens to the planet, not with trembling hands, but with sensors, with satellites, with silent data streams. Seismographs mark tremors, too faint for your feet to feel. GPS monitors land that rises by millimeters over years. Thermometers measure steam escaping from hidden faults. It's all quiet, gentle, methodical. There is no room for fear here, only awareness. The earth, after all, speaks in pulses, in slow uplifts, subtle tilts, faint gases. When science listens, it does not react to records. At Yellowstone, hundreds of instruments lie nestled in the landscape, some in open air, others deep underground. Together, they form a kind of stethoscope, placed gently against the chest of the earth. They listen to its breath, tate its heartbeats. If the land swells, they take note. If the ground quivers, they compare it to yesterday's rhythm. If new gases hiss, to the surface sulfur dioxide, carbon dioxide, hydrogen sulfide. Scientists gather samples and look for patterns. Patterns, that's the key. An eruption, even one as large as a supervolcano, doesn't arrive unannounced. Preceded by a symphony of subtle changes, small earthquakes, uplift, gas emissions, shifts in groundwater temperature. Each is a note. Science reads the sheet music, not to panic, but to play along with understanding. And it plays with a sense of peace, because science is not about worst-case scenarios, it's about preparing for all scenarios. There are protocols in place. Simulations run constantly. Governments hold drills. Key emergency services are briefed on volcanic contingencies. Key models predict ash dispersal, evacuation routes, air traffic disruptions. But all of this hums in the background, like a low, reassuring heartbeat, like a lullaby that says, we're watching, we're ready. you can rest. The United States Geological Survey, USGS, maintains the Yellowstone Volcano Observatory. Scientists don't sit in bunkers, they walk the parks, take samples by hand, publish calm monthly updates. A tone is never alarmist. It doesn't need to be. The earth is not screaming, it's whispering. And they are listening closely. Sometimes the land swells a little. Sometimes it sinks again. This is normal. This is expected. Yellowstone, like all living systems, breathes. And science knows the difference between a breath and a roar. Even supervolcanoes, with all their potential, are creatures of rhythm. Their cycles are counted in tens of thousands of years. Not in news cycles, not in human lifetimes. The last major Yellowstone eruption was around 640,000 years ago. Before that, 1.3 million years ago. These are not events that sneak up on a Tuesday afternoon, and so we watch. Not with fear, but with fidelity. Because watching the earth is not about controlling it, it's about respecting it. Respect leads to readiness. Readiness leads to calm. This is the heart of the scientific mindset. Not denial, not panic, but a middle space, a tranquil balance between knowing what's possible and understanding what's likely. Children play on trails that cross ancient fault lines. Families camp above vast magma chambers. And scientists walk beside them, clipboards in hand, quietly keeping watch. In Iceland, where volcanoes erupt more often, life doesn't freeze when the land shakes. People pause. They listen to updates. They adjust their routines, but they keep going. Because when science becomes part of the culture, fear fades. People learn how to live alongside uncertainty. They trust the observers. They trust the data. They trust that someone, somewhere, is watching the sky and the ground with care. And that trust, that's what makes sleep possible tonight as you drift beneath your blanket. Know this, the earth has been here for over 4.5 billion years, has erupted and reformed, shaken and settled, cooled and heated over and over again, and through it all, life adapted. You are part of that adaptation. You walk through forests built on past eruptions. You drink water filtered through volcanic rock. You breathe air shaped by ancient skies, darkened with ashdot, and still the stars shine. Still, your lungs expand gently with breath. Still, your thoughts slow as you lie, listening to this story. Because knowledge is comfort. Knowing that magma exists beneath your world doesn't mean you live in danger. It means you live on a planet that's alive, that's dynamic, miraculous in its constant change. And we humans, thinkers, listeners, have evolved not to fear that change, but to study it, to track it, to speak about it in ways that calm the heart. Think of the satellites orbiting overhead right now. They're not flashy, they're steady. They take measurements day after day, watching ground deformation, measuring gravity anomalies, capturing thermal images from space. They see the earth not as a place of sudden fear, but as a canvas of movement, slow, predictable, beautiful. They watch the calderas of Indonesia, the hidden magma beneath Lake Toba, the scars left by past events, now overgrown with moss. They paint a portrait of a planet that is old and wise and peaceful. Most of the time. And when it's not peaceful, when a volcano rumbles louder, or ash begins to rise, science responds, not with sirens, but with plans, with communication, with clarity. That's what keeps us safe. That's what lets you rest. Because fear only grows in silence. But science is not silent. It speaks through articles, through updates, through shared knowledge. And in that language of calm, we find our footing. You don't need to study geology to feel this comfort. You don't need to understand fault lines to appreciate the earth. You only need to trust that the watchers are watching, that the planet is speaking softly, and that someone somewhere is always listening. So tonight, As you listen to the quiet around you, know that far below the crust, magma sleeps, and far above the clouds, satellites float. Between them, you lie cradled by a world that moves slowly and by minds that watch gently. There is no alarm here, only attention, only peace. And if one day the earth stirs louder, we will hear it. Not because it will shout, but because we have learned to hear its whisper. That is the gift of science, not predictions, but presence. And with presence comes peace. You can close your eyes now, because someone is awake, listening to the hum beneath your feet. And in the space between vigilance and stillness, we begin to understand how the quiet holds everything. You live on a sleeping world, not lifeless, not still, but asleep in its deepest layers. Beneath your home, beneath cities and oceans and forested silence, the earth breathes in rhythms too slow to feel. This slowness is its nature, its restraint, the immense quiet that holds everything in place. You rarely think of the crust beneath you, just a thin shell on an ancient planet, but it is enough. This fragile lid of rock, floating above molten possibility, carries your cities, your forests, your dreams. You walk across it, you sleep on it, you build upon it without ever hearing the sigh beneath. That sigh is not danger, it is balance, because for all we know of eruptions of ash-filled skies and ancient fire, what we experience most is silence, stillness. Supervolcanoes do not define the daily mood of the earth. They do not roar every decade. They sleep. In their sleep, they allow the world above to flourish. Imagine Yellowstone not as a threat, but as a reminder. A vast, breathing caldera that could erupt, but chooses day after day not to. Under geysers and hot springs, beneath herds of elk and trails of mist, lies the calm pulse of molten rock. But it does not rise. It does not demand. It waits. And this waiting is what makes everything else possible. Waiting is underrated. In geology, in life, we like stories with events, disaster, action, certainty. But the earth prefers stasis, prefers the slow, if you listen not to the headlines, but to the soil, you begin to understand that peace is not boring. It is miraculous. There are hundreds of volcanoes around the world. Many rumble, a few erupt, but the overwhelming majority remain silent, holding their fire, letting moths creep and birds settle and civilizations grow careless. The earth, more often than not, keeps its peace, and so do the supervolcanoes. A supervolcano is not super because it screams louder or rises higher. It is super because of the scale of its potential. And yet, it is the very scale of that potential that seems to require silence. If these vast reservoirs of heat and pressure erupted as often as their smaller cousins, the world would not be what it is. There would be no agriculture, no cities, no continuity. Their quietness is not accidental. It is essential. Scientists monitor them not because they are loud, but because they are so very quiet. Any breath, any swelling of the ground, any tremor, these are watched with reverence, like a heart monitor for the planet itself. But most days, there is only the slow tick of stability. It is in this steadiness that life thrives. On the slopes of old calderas, forests grow. In the soil enriched by past eruptions, crops flourish. Even the destructive past becomes a bed for growth. That is the rhythm of earth destruction, yes, but separated by long, generous pauses. Time enough to recover, to rebuild, to forget. And forgetting is part of the cycle. 2 generations pass with no eruption, and so people settle, build homes near ancient scars, unaware or unafraid. Towns rise on lava beds, schools are built beside bubbling springs. Roads cross fault lines. Life returns because the earth allows it to, because the fire beneath has not stirred. And perhaps That's the most remarkable thing. Not that volcanoes erupt, but that they don't. Not often, not loudly. Just enough to remind us that silence is not emptiness. It is choice. It is held. Pressure. It is the weight of something immense, choosing not to move. You live your days by sunlight, by seasons, by hours. The earth lives by eons. It builds mountains with pressure. It carves valleys with time. It carries entire plates across the mantle like slow rafts drifting on a sea of stone. And in all of that motion, there is so much calm, so much pause, so much that doesn't erupt, doesn't collapse, doesn't break. We are taught to fear supervolcanoes, and it's right to respect them. But fear misplaces the focus. It paints them as ticking bombs when they are, more truly, sleeping giants with no alarm clock. They do not keep schedules. They do not make threats. They simply exist, okay? And in their stillness, they give the world above space to breathe. Think of your life, the millions of steps you've taken, okay? The dreams you've had, the nights you've slept, all above these quiet furnaces. Has Yellowstone interrupted you? Has Toba? Has Campy Fleegray? No, because these places are not in a rush. Their story is longer than yours. They will outweigh empires. And even when they do speak, it will be in the language of pressure and time, not malice, not rage, just geologic necessity. And in the spaces between those rare eruptions, the world spins on. Children are born. Books are written. Trees grow ring by ring. And people forget, again and again, that they live on floating rock above flowing stone. That forgetting is both dangerous and beautiful. Dangerous because unawareness breeds unpreparedness, but beautiful because it shows how deeply the world trusts the quiet. You don't walk across a parking lot worrying it might collapse into lava. You trust the crust. You believe in a pause. You sleep soundly. That trust is not foolish. It is earned every day by the earth's restraint. Every non-eruption is an act of grace. Every silent day is a gift of time. And yet, beneath that calm, pressure does build slowly, without urgency, without sound. The magma does not forget where it lies. The heat does not vanish. It waits. And the earth, so patient, so vast, holds it there with pressure and density and ancient design. But pressure is never permanent. It shifts, seeks balance, and one day, somewhere, a vent may open. That will be its own chapter, its own story. And it may come long after your lifetime. For now, there is only the quiet, the lull between pulses, the breath between epochs. And in that breath, you live, you work, you love, you sleep. You forget. The supervolcano sleeps to not snoring, not shifting, just resting beneath your cities, beneath your lakes, beneath the echo of ancient eruptions, now covered in soil, in forest, and time. You don't need to watch it every second. You don't need to worry, because the earth is not a trap, is a cradle. It has held life through fire and ice, through impact and upheaval, and through it all, most of the time, it's quiet. That quiet is what holds the world together. And yet, even the most silent dreams must shift. Next, let us gently descend into the warmth beneath your feet to where ancient fire rests. Dreaming, not of chaos, but of possibility. Beneath you, fire sleeps, not extinguished, not forgotten, quiet. It's there. You live in a world layered with hushed stone above silence, soil above story. And under all of it, deeper than your deepest thoughts, lies heat. Ancient, brooding, unhurried, kind of dreaming the earth does in its own time. This is not the fire of stoves or torches. Okay. It is not the blaze of a candle or the orange flicker of flame you hold in your hand. No, this fire cannot be held, cannot be rushed. It is folded into the rock, woven through minerals, tucked beneath fault lines and basins. It sleeps beneath forests and highways in neighborhoods where children learn to count stars. You never see it, but it is always there. You live your life on the cooled skin of a planet that is still warm in its marrow, and that warmth is not spent. It is gathering. It is slow, circular, dense with waiting. Beneath Yellowstone, beneath Toba, beneath Long Valley and Topo, and the sleeping calderas of the Andes. Magma hums like a lullaby too deep to hear. You do not need to hear it. You already feel it, in the way geysers burst upward like exhalations, in the way the earth swells, then rests, in the strange, sour scent near fumaroles, in the warmth that seeps through stone in places where the crust is thin. These are the signs of dreaming, the small gestures of fire that sleeps but does not forget. We call them supervolcanoes, as if their identity comes from what they can destroy. But that is only one side of the story. These vast reservoirs are not engines of ruin. They are deep stores of energy that has shaped continents, ridden climates, carved skylines. They are not threats. Okay? They are origins. Look back through the layers of time and you'll see it. Civilizations that grew in the rich soil of old eruptions. Ecosystems fed by mineral ash. Valleys formed not by erosion, but by collapse the roof of a magma chamber sinking slowly into itself. You stand atop the aftermath of ancient dreams, and those dreams continue. Fire sleeps, but it dreams of pressure, of form, of ascent. It tests the stone that holds it. It warms and shifts and waits, not with intention, but with inevitability. It does not plan, but it persists. Some chambers swell, then shrink again. Some send steam through cracks. Others remain still for centuries, barely stirring, content to do nothing but hold heat. And yet they are alive. Geologically alive, not in the way of hearts or lungs, but in the deep rhythms of planetary breath. Every now and then, the breath hitches. The land lifts a little. A tremor whispers beneath your feet. Still doesn't mean eruption, because most dreams never rise to the surface. Fire can dream for 100,000 years and never wake. It can gather beneath your feet and change nothing. You, above, continue walking trails, planting trees, building homes over the skulls of past eruptions, now grown soft with moss. But the dream remains. You live in that dream, whether you know it or not. It shapes the land beneath you. It writes the rules of what can grow, what can flow, what can be built. And sometimes it stirs the sky. Think of the distant past when Tambra erupted and sunsets blushed purple for years. When Toba dimmed the planet and perhaps changed the arc of humanity. When Lagareya exploded into the sky before there was memory to record it. They were not explosions alone. They were resets, rewrites, rearrangements of the possible. And still, the world moved on, because even fire that dreams is part of life, part of the balance. The earth does not simply endure eruptions, evolves through them. The land becomes new. The air shifts. The oceans learn a different rhythm, and you, your kind, adapt. There is a strange peace in that, in knowing that even the fiercest forces of nature do not always destroy. They also renew. They feed, they sculpt, cradle what comes next, but only after long silence, because the earth prefers quiet. It dreams more than it screams, and that is what the supervolcano teaches, most of all. Not how to fear, but how to listen, how to respect the hush, how to live in a world where the ground beneath you is not fixed, but faithful. Not always come, but mostly. And in that mostly, life is possible. In that mostly, you build, you stand on this thin crust and feel so sure of its permanence. But you also know somewhere deep in your bones that it is not permanent, that everything solid is secretly soft, that everything still is only paused. That is not a reason to fear. Keyed is a reason to wonder. Because the wonder is this: how stable it all is, despite how unstable it could be. How the fire beneath has held itself in sleep for thousands of years, so that you could sit by lakes, climb trees, fall in love, and when you sleep tonight, the fire will still be there, curled beneath you like a forgotten god. Not angry, not waiting, just present, just possible. It does not ask for worship. It does not demand belief. It simply is in you. Get to be here now, during the pause. That is the gift. That is the story. A story where the main character is silence, where the climax may never come, where the drama is hidden under centuries of snow and soil, where you, reader of the stars and sleeper of dreams, are held by stone thinner than your faith, and yet thick enough to carry your whole life. You do not need to know when or how or if. You only need to know that beneath the quiet, something vast breathes with you. Something timeless, something older than sky, and it is dreaming still. Let it, because fire that dreams is not the end. It is the beginning of something else.